Bismillahirrahmanirrahim. Welcome to the lecture 5 part 2. The first topic in the lecture 5 part 2 is symmetric cryptography. So what is a symmetric cryptography? Symmetric cryptography is much faster than asymmetric, but symmetric cryptography brings with it the issue of key exchange, so it was difficult to determine which was best to use when designing a secure infrastructure. There are two basic techniques for encryption: private key encryption, also called symmetric, and public key. So students, in this slide, what you have to understand is, if you take the cryptography, okay, encryption and decryption technique, it is classified into two types. One is symmetric and another one is asymmetric. So the cryptography algorithms are classified into two types: symmetric and asymmetric. The symmetric encryption can also be called as private key encryption. So this one you can call it as private key encryption, and the asymmetric can be called as public key encryption. Okay, public key encryption. So in the symmetric encryption technique, please understand, same key is used for encryption and decryption. In the public key encryption, or you can call it as asymmetric, there are two keys used. One is public key and another one is private key. Let me do the recap of this introduction of the symmetric and asymmetric algorithm. The cryptographic encryption algorithms are classified into two types: symmetric, asymmetric. The symmetric encryption algorithm can also be called as private key encryption. Asymmetric can be called as public key encryption. The private key or the symmetric encryption technique uses the same key for both encryption and decryption, whereas the asymmetric uses two different keys. One is public and another one is private. So this is what discussed in this slide. Symmetric key cryptography, also known as private key cryptography, utilizes a single key for both encryption and decryption. The key itself must be shared between the sender and the receiver, and this process is known as key exchange. It is possible for an attacker who has managed to intercept it to decrypt the message, or worse, to decrypt the message, alter it, then encrypt once more and pass it on to the receiver in place of the original message. Symmetric cryptography by itself provides only confidentiality and not integrity. Okay, so what is given here? Let me explain. So now you take a message, okay, this message you can encrypt so we are discussing the symmetric encryption technique. So the message to encrypt, you use the secret key or you can call as private key. So what you get when you encrypt something, what you get is cipher text. It is encrypted data. Now again you decrypt using the same key. Okay, then what you get? The message. The message before it is encrypted, it is called plain text. Okay, so after decryption you get the message, once again it is in the plain text. So you can see in the symmetric encryption technique, same key is used for both encryption and decryption. Okay, no two different keys, same key has to be used for encryption and decryption. Okay. Now students, now let me type a message, hello. This is the plain text, or we can call it as a message. Now I am going to encrypt using symmetric encryption algorithm. Now I am entering the key. The key is this 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we have 10 letters, then 8, 7, 6, 5, 4, 3. So actually I need 16 letters. Okay, so this is the key, students. It can be any numbers, just you can put any key size, I mean any key you can enter. Now I am going to encrypt. Okay, so now this is encrypted data. Okay, students, it is symmetric. The AES is a symmetric encryption technique. This is the plain text and this is the key. Okay, this is the cipher text. Okay, this is cipher text. Now let me copy the cipher text. I am going to do the decryption. So this is cipher text. Now you have to use, okay, now let me try to decrypt. It is telling it cannot decrypt because it needs the key. Okay, let me give some other key. I copy this key, I just copy the key, I change the key. Okay, so it's not working properly. Now let me put the same key. Now you can see we got the plain text. So what you understand is the same key is used for encryption and decryption. So this is called symmetric cryptographic algorithm. The same key has to be used for symmetric cryptographic algorithm. So now I am giving you an exercise with a diagram. Show the symmetric encryption. Okay, so you can show like this: message, then encryption. So to do the encryption you need a key. Okay, so you can say secret key, then you do the decryption, use the same secret key. Okay, so you get the message. So this message is the plain text, and here you get the cipher text. Okay, so this message and this message is the plain text. Okay, now in the symmetric encryption technique, please understand, okay, there is no authentication. You cannot verify the integrity of the data. Okay, if suppose somebody changing the data, there is no way to verify the integrity of the data. Okay, so and also the sender, okay students, listen, I just divide like this. So this is sender and this is the receiver. Both should have the same key. That is called key exchange. The sender has to send the key to the receiver. They should have the same key. So the exchanging the key is not so easy when you use a symmetric encryption technique. So it is possible for an attack. Okay, now here the point. There is a confidentiality, please understand. Whenever you are using the encryption technique, there is confidentiality. But understand, you will not get the integrity. Integrity means if suppose the data is modified, changed, it cannot be detected. Next one is, so what is a key exchange? It utilizes a single key for both encryption and plain text, decryption of the cipher text. So please understand, in the symmetric encryption technique, both sender and receiver, for both encryption and decryption, same key is used, and the key has to be sent to the receiver. So the sender and the receiver, they have to share the same key. Sharing, that is called key exchange. The key must be shared between the sender and the receiver, and this process is called as key exchange. So what is a key exchange? Okay, so what is a key exchange? So here you can see the key has to be shared between the sender and the receiver. This process known as key exchange. Next one is, what is block versus stream cipher? What is block versus stream cipher? A block cipher takes a predetermined number of bits known as block in the plain text message and encrypt the block. Blocks are commonly composed of 64 bits but can be larger or smaller. Okay, so what it means, students, for example, you see so now you have 8 bits. You have a block and this block has 8 bits. Okay, so this block goes as an input into the encryption algorithm. Okay, then you use the key and you get the cipher text. So here the encryption is happening as a block. Okay, predetermined set of bits, okay, group of bits, they form a block, and the encryption algorithm uses the block of data as an input. Now suppose you see only one bit is encrypted at a time. Okay, only one bit at a time, then this is called stream cipher. This is called block cipher. You can see group of bits together, they are encrypted. This is block cipher. Here if you encrypt bit by bit, one bit at a time, then it is stream cipher. So a block cipher takes a predetermined number of bits known as block, okay, and then encrypts the block. A stream cipher encrypts each bit, okay, in the plain text, one bit at a time. So now you can ask, what is the size of this block? It can be 8 bit or it can be 64 bit or it can be 188 bits or it can be 256 bits, like that, so on. Clear? So what is a stream cipher? What is a block cipher, students? Please find the answer here. A block cipher takes group of bits. If you find difficult to use this word, you can say a block cipher takes group of bits known as a block as a plain text, okay, to do the encryption. The stream cipher encrypt one bit at a time. Very simple. Clear? Now these are some of the examples of symmetric algorithms. Students, these are the examples of symmetric encryption algorithm: DES, triple DES, AES. Okay. So now we are going to discuss about the asymmetric cryptography. Cryptography involved the use of two keys, a public and private key. Okay, so let's discuss. So asymmetric cryptographic algorithm. Okay, it uses two keys. One is public key, another one is private key. There are two keys. You can go back in the symmetric encryption algorithm. How many keys are used? Only one key, secret key, or you can call it as a private key for encryption and decryption. But in asymmetric, two keys, public and private keys. So let's take a message M. So whenever I say M, it refers to the plain text. Now you are encrypting. So let's say this is a sender. Okay, so there is a sender here. So let's say there is a receiver. Okay, this is the sender, this is the receiver. Understand? So here the sender would have two keys. Okay, so he would have a public key of sender, then you would have a private key of sender. Please understand, here they are writing like this, but this is a good convention. Public PUB, public key of sender, private key of sender. Similarly, the receiver would also have two keys. So you would have two keys. One is public key of receiver and private key of receiver. So both sender has two keys, public key of sender, private key of sender, and receiver has two keys, public key of receiver and private key of receiver. This public key, please understand, it is open. They can share with others. The public key of both sender and receiver, they can share with each other. They can share with anyone. But the private key should not be shared. This is very secret. This should be very secret. That's why I am putting a circle. They should not share this key with others. It should be kept secret. Understand? So now let me show the scenario. So now you see there is a message. This message is encrypted using the okay, so public key of receiver. See, the public key of receiver is shared. So the receiver share its public key to the sender, with sender. So the sender, what he does, take the message and encrypt the message using the public key of the receiver. Now you have the cipher. Now you are sending this to the receiver. Now the receiver, what he does the decryption. So decryption he does using his private key of receiver. So please understand, the message is encrypted using public key of receiver. So the message, when it goes to the receiver side, it should be decrypted using the private key of the receiver. Please understand, the key should be matching. So these two keys have the relationship, they are matching keys. These two keys are matching keys. You should not mix them. And if you are using the public key of receiver, you should not try to decrypt using the private key of the sender. And also, when you are using the public key for the encryption, then you should use the private key for decryption. You cannot use the same key for the encryption and decryption in the asymmetric cryptography. Okay? And the encryption and decryption, you should use the matching keys, the keys which they have the relationship already. When you create the key, already you have created the relationship. Okay, now when you do the decryption, you get the message. Okay, students, so please understand, you have the message. That message is encrypted using the public key of the receiver. You can ask how the sender knows the public key of the receiver, because the receiver shared his or her public key to the sender. Using that, the message is encrypted. Now the decryption is done using the private key of the receiver. Okay, so you should not use the keys which are not matching. So these keys are matching. So this key is used for encryption, then this key should be used for decryption. Suppose if this key is used for encryption, then this key should be used for decryption. So this is the scenario 1. Okay, so in the scenario 1 okay, in the scenario 1, please understand, there is confidentiality. What about the authenticity? So what is authenticity? The message is encrypted. There is a cipher. The cipher text is going through the internet network. If somebody hack, they cannot see the message because the message is encrypted. And if they want to do the decryption, if they want to see the message, they have to do the decryption. But this guy, he cannot do the decryption. Why? Because this guy doesn't have the private key of the receiver. The private key of the receiver is very secret. The receiver will not share with anyone. So the attacker cannot see the message. When you encrypt the message with the public key of the receiver, and when you decrypt the message using the private key of the receiver, please understand very carefully, then there is confidentiality. If there is confidentiality, the attacker cannot see the message. However, there is no authenticity. there is no way you can verify that, the receiver can verify that this message really came from the sender. Maybe the attacker also can send the message in the name of the sender. This is called spoofing. Okay, this attacker can send the message acting like the sender. So there is no authenticity in this scheme. So when you encrypt with the public key of the receiver and when you decrypt with the private key of the receiver, okay, so scenario 1 means for encryption, okay, public key of the receiver is used. For decryption, private key of the receiver is used. So in this situation there is confidentiality. Attacker cannot see the message, but there is no authenticity. That means attacker can send the message acting like a sender. Okay, there is no way to verify that this message really came from the sender. Now second scenario 2. In this scenario, please understand, okay, sender has 2 keys, already you know. One is public key of sender, I make it short, private key of sender, then receiver has 2 keys. One is public key of receiver, I write short, private key of receiver. So this key is very secret. Okay, so I just put a box. Now you have the message. Now you are encrypting the message with the private key of the sender. You see the difference. Not public key of the receiver, but private key of the sender. And you are sending the message to the receiver. So receiver decrypt. Please understand, if private key of the sender is used, then for decryption you should use the public key of the sender, because these keys are matching and these keys are matching. So don't mix the keys, keep this in your mind. So private key of sender is used for encryption, then public key of sender should be used for the decryption. So you get the message. In this scheme, please understand, there is no confidentiality. There is no confidentiality. Confidentiality maafi maugut. But there is authenticity. Because when you send this cipher text, it can be decrypted using the public key of the sender. This public key of the sender, already I told you, it can be even with the attacker. The attacker is here, because the public key anybody can have. He also, the attacker also, he has the public key of the sender. So he can capture the packet and he can see the plain, decrypt and see the plain text. So there is no confidentiality. When you encrypt with the private key of the sender and decrypt with the public key of sender, there is no confidentiality. However, there is authenticity, because if you are encrypting with the private key of the sender, nobody can have the private key of the sender. Only sender have the access to the private key. It cannot be shared with others. So when you encrypt with the private key first, there is authenticity. but there is no confidentiality because you are trying to decrypt using the public key. When you try to decrypt using the public key, everyone in the network they can have the public key, so there is confidentiality missing. So scenario 2, there is no confidentiality, but here there is confidentiality. Is it clear to you, students? Now let us practice. Now draw a diagram using asymmetric scheme, which does not have confidentiality, but there is authenticity. So this is scheme 2. Message. So you have the encryption. Okay, so you have confidentiality. So please understand, for confidentiality, if you want confidentiality, then you have to use the public key of the receiver. This is receiver, this is sender. So if you want the confidentiality, you have to use public key of the receiver. Okay, then only you will get the confidentiality. Then for decryption, you should use the private key of the receiver. Then only you get the confidentiality. So in this scheme, there is confidentiality, but there is no authenticity. Clear? So confidentiality is there. Oh, I am sorry, I made a mistake. Which have confidentiality, but there is no authenticity. We change this now. Fee confidentiality, have confidentiality, but there is no authenticity. So when you want confidentiality, you should encrypt using the public key of the receiver, and you should decrypt using the private key of the receiver. If you do like this, if you use this key pair, then there will be confidentiality, but there will not be any authenticity. Understand? Sorry students, now it's very clear. I made mistake in the initial. Okay, now there is confidential. Now we will do one thing. Draw a scheme using asymmetric technique. So in this there is authenticity, but no confidentiality. Okay, there is no confidentiality. Okay, there is authenticity, but there is no confidentiality. Okay, so how you do message encrypt. So okay, you want authenticity. Okay, you want authenticity, but you do not want confidentiality. Confidentiality maafi mawgood. So if you want authenticity, then you should use the private key of the sender. Okay, go back. So private key of the sender. If you use there is authenticity. Then take the decryption. For decryption, so if you are using private key, then you should use public key of sender, you have to use for decryption. So now please understand, there is authenticity but there is no confidentiality. Here there is confidentiality but there is no authenticity. Okay, all depend on what key you are using for encryption and decryption. Clear to you? Now we want both confidentiality and authenticity. Now we need both. Okay, we will work that now. Now we want both the confidentiality and authenticity. So what we have to do, we have to use both the key pairs. Message, okay, there will be two encryption. So this is encryption number 1. So for that we have to use the key private key of the sender. Okay, so private key of sender is first used to do the encryption. Then again one more encryption. Okay, I write the encryption in short. Okay, here the key is used is public key of the receiver. Public key of the receiver. Now okay, so there will be two decryption. So first decryption, this. Okay, for this which key should be used to do the decryption? Private key of the receiver. So this is the decryption. So private key of the, because it is encrypted using public key of receiver, so private key of receiver is used. Then again one more encryption, decryption. So I write in short. So now this key. So for this, okay, which key is used? Private key of the sender. So here public key of the sender is used for the decryption. These are matching keys. Now what you get is message. So in this scheme, students, since you are using the private key of the sender for encryption and using the public key of the sender for the decryption, you have the authentication, authenticity. And here you are using the public key of the receiver and the private key of the receiver, so you also have the confidentiality. Okay, so you have both authenticity and confidentiality, students. So this diagram clearly shows the authenticity and confidentiality. So in the first scenario, the case 1, so this is the case 1, the public key of the receiver is used and the private key of the receiver is used. So there is confidentiality but there is no authenticity. So in this scheme, okay, case 1. In the second case, you are using the private key of the sender for encryption and public key of the sender as the decryption. So in this scheme there is authenticity but no confidentiality. I explained with my diagram already. So in the case 1 there is no authenticity but confidentiality, anybody can send the message. In the second scenario there is authenticity but no confidentiality, anybody can receive the message if they have public key of sender. So both authenticity and confidentiality, how to do that. So I have explained with this diagram, which is very clear, okay, which there is no ambiguity, no confusion, because here you know what is which private key, sender private key, public key of receiver, private key of receiver, public key of sender. So it is better than, this is better than what is given in the slide. Clear? Yeah, even here it's given clearly. I'm sorry, it's given clearly, but it's up to you. Whichever is convenient for you, you can follow. So these are the examples of the asymmetric cryptographic algorithm, RSA algorithm, and elliptic curve, this example for asymmetric cryptographic algorithms, students. Okay, Diffie-Hellman, then DSS, okay, L-Gamal. All these are examples of asymmetric cryptographic algorithm. So please remember the names which are asymmetric cryptographic algorithms. Is it clear to you? Similarly, earlier we discussed what are the examples of symmetric cryptographic algorithms. So DES, triple DES, AES, these are symmetric, and this one is asymmetric. Now, what is a hash function? So one more thing, let me show you. So here RSA encryption, asymmetric also I want to show on RSA So first you should create a key pair. So this is public and private key. Okay, now hello, I am going to encrypt. So you need a public key. Any key you can use, public or private, but if you are using public, then you should use a private for the decryption. So I am using the public key for the encryption. Okay, then encrypt. This is the encrypted data. Okay, so this is the encrypted data. Now I copy this, I put it here to do the decryption. So now I use the public key for encryption, then I should be using the private key. So we have the private key. So we got the plain text. So please, this is the plain text, this is the public key which is used to do the encryption. Okay, this is the cipher text. Now you put the cipher text here, then use a private key. Don't use the same key. Public means private, private means public. You should use the opposite key. Okay, and you see when you create the key, you get a key pair. Okay, you get a key pair like this. So this key is related to this key and this key is related to this key. That's called key pair. You can create any number of key pair like this. Understand? And this is the key size. If you want bigger key size, you can have bigger key size. If you want smaller key size, then you can have smaller key size. But the security depends on how much key size you are using. Next one is called hash function. So next, what is hash? So now I type hello. Okay, then this is the hash value. Okay. So this the input can be any message, but you get a fixed size pseudo code. Okay, that is called as hash value. Okay, if you change the value here, then the hash value also changes. If you change, you can see it is changing. Okay, so from the hash value, suppose I give this to someone, okay, and asking the person to find what is the plain text, it is not possible. It is very difficult. So it's a one-way function. Okay, so from the plain text you get the hash value bus colors. So it is not same like encryption and decryption. In encryption, when you encrypt the data, again you can decrypt and convert into plain text, but in hashing you cannot do. Okay, so the plain text, when you convert to hash value, you cannot reverse this value to a plain text. Okay, so hash functions represent a cryptographic type alongside the encryption and decryption algorithms. So it belongs to the cryptographic family: hashing, encryption, decryption, hashing. These all comes under the umbrella of cryptography. Hash functions referred to as message digest. So another name for the hash value, hash function, is called message digest. So this is called hash value or message digest. Please understand. So these hash values are fixed size. This is hexadecimal value, but if you convert into binary bits, the length of the binary bit is 512 bits. Okay. So hashes are very useful when distributing files or sending communication, as a hash can be sent with a message so that the receiver can verify the integrity. Very important. So hash values are used to check the integrity of the data. When you are sending some message, okay, to the receiver, okay, the hash values are used to verify the integrity of the message. The receiver simply hashes the message again using the same algorithm, then compares the two hashes. So students, if I draw the diagram, you will easily understand. Okay, see, hashing. Okay, you take a message. The message, what you do, you calculate h means hashing. So this is h of m, hash value of the message. Okay, this is called hash value of the message. Now you take the message, you add the message and the hash value. So now what you have is the message and the hash of the message. Okay, now you can ask teacher, how hash of message? So like this, okay, you calculate this is the message, this is the hash of the message. So you are combining them together, message and hash of message, you are sending to the receiver. The receiver what he does, so the receiver has the message, hash of message. The receiver again he calculate the hash value, then he get again hash of m again. Now you have this hash of m, okay, which is sent by the sender, hash of m. Okay, now you just compare, or verify. Okay, if they are same, data message not changed. So that means the message not changed while it is transmitted across the network. So when you calculate the hash again in the receiver side, okay, and this hash sent by the sender, they are same, there is no difference. If there is no difference, if they are same, then okay, that means the message not changed. If they are different, that means the message has been changed. So hashing is used to verify the integrity of data. It is used to verify the integrity of data. So students, okay, now I am once again okay, how to use the hash to verify the integrity of the data. Message, okay, calculate the hash. So what you get is the message and the hash of the message. The receiver, what he does, again he calculate the hash, so he get his hash of m, then you compare the receiver hash of compare, okay, and find whether the message changed or not. If they are same, the message not changed. If they are different, the message, sorry, if they are same, the message not changed. If they are different, the message has been changed. So this is how to use the hashing to verify the integrity of the data. So students, hashes are very useful when distributing the files. Okay, so whatever I explained, same thing is given as a descriptive one. Hashes are very useful when distributing files or sending communication. The hash can be sent with a message so that the receiver can verify its integrity. Okay, so integrity, the receiver simply hashes the message again using, so the same thing I have explained using the diagram. Clear to you? How hash can be used to verify the integrity. Then MD5, SHA-3, these are examples of the hashing algorithms. Clear to you, students? Okay, so this diagram shows how hash can be used to verify the integrity of data. or message. Same thing is given here. So what is a digital signature? Digital signatures are great example where the hash function is used. Digital signature allows us to sign a message in order to enable detection of changes to the message content, to ensure that the message was legitimately sent by the expected party, and to prevent the sender from denying that he or she sent message. To digitally sign a message, the sender would generate a hash of the message and use a private key to encrypt the hash. So again students, very easy concept. So digital signature. So digital signature. Okay, what is digital signature? I show whatever here in the description. I will show with a diagram. You have the message, take the message, hash the message. Okay, hash the message. Then you have the h of m. Then what you do, you encrypt the message using the private key of the sender, and what output you get is called digital signature. So take the message, do the hashing, this is called hashing, and then what output you get, hash of the message, and the hash of message is encrypted using the private key of the sender, and the output what you get is the digital signature. The digital signature is used for non-repudiation as well as to check the integrity of the data. So you can see here, this is integrity of the message content to check the changes. This is non-repudiation. The message was sent by the expected party. Okay, this is authentication. Sorry, this is authentication. And third one is non-repudiation, to prevent from denying he or she did not send the message. So this is integrity, changes to the message contents. If any message has been changed, it will affect the integrity. To verify the integrity, signature can be used. And also to know authenticity, whether it is sent by the right person, that's called legitimately sent by the expected party. Okay, signature can be used. And also to prevent someone denying that he or she did not send the message. Someone sent the WhatsApp and later tell I did not send. Someone sent the email, later say he did not send. That's called repudiation. So please, it can be used for authentication, integrity of data check, and non-repudiation. And what is a digital signature? Students, if you cannot tell in English properly, you can use this diagram. Message, hash the message, okay, then encrypt the message using the private key of the sender. Okay, the output what you get is the digital signature. That is what is explained this area. Okay, I have shown with a diagram. Clear? So next concept is called certificates. In addition to hashes and digital signatures, we have another construct by which we can scale up the use of message signing. in the form of digital certificates, commonly known as certificates. Certificates are created to link a public key to a particular individual and are often used as a form of electronic identification for that particular person. A certificate is typically formed by taking the public key and identifying information such as name and address and having them signed by a certificate authority. So students, these are very big concepts. I will explain them just a minute. So now let's say I go to this website, Bank Muscat. Now if you go to any secured website, in the secured website you can find certificate. These secured websites, they send their certificate to our browser. In that, okay, so this certificate actually belongs to the Bank Muscat example, and if you open the certificate, there is a public key of the Bank Muscat. Okay, earlier you studied about what is public and private key. So this public key belongs to Bank Muscat. We cannot see the private key because private key is kept secret. Okay, so the public key of the Bank Muscat has been added into this certificate. Clear? So the certificate contains lot of details about the Bank Muscat and also about the different hashing algorithms, encryption algorithms which are used. Okay, and this certificate actually is given to the Bank Muscat by a company called DigiCert. So this DigiCert actually can be called a certificate authority. So this is a company which issues the certificate to the bank, the entities like Bank Muscat. Understand? So the certificate actually includes the public key of the entity as well as it contains the information about the entity, example Bank Muscat. Understand? And this certificate has been issued by the certificate authority. So now you can understand. Certificates are created to a public key. It contains the public key of the individual. Okay, example, in the certificate of the Bank Muscat you can find the public key of the Bank Muscat, and it is used as a form of identification. It is used to authenticate the Bank Muscat site server. It is used to identify. It's a form of electronic identification for the particular person. Example, to authenticate the Bank Muscat, to authenticate the NBO bank, to authenticate the Facebook, to authenticate the Instagram, etc. A certificate is typically formed by taking the public key and identifying the information such as a name and address and having them signed by a certificate authority. So please understand, inside the certificate you have the public key of the owner, the company, okay, like Bank Muscat, and also there are some information about that company. Okay, then this certificate is created by another organization which is called as certificate authority. Certificate authority. Okay, so who create the certificate? Certificate authority. And inside the certificate what you have? You have public key of the owner. Owner means, example, Bank Muscat, NBO bank, Instagram, Facebook. And this certificate is what is the use of the certificate? Like your ID card, it is used to identify a website. It is used to authenticate a website to the client browser. Understand? So here certification authority, they create the public key. I'm sorry, they create a certificate. In that certificate they put the public key of the owner, the entity, example Bank Muscat. Okay, the entity provides the proof of identity to the certificate authority. Just a minute, I will show one diagram, you will understand very clearly. So basically what happens is that about some entity, okay, like public key, all are inserted into the certificate, it's hashed, okay, then it's encrypted using the private key of the certificate authority, a signature is created and the signature is added with the certificate. But now let's discuss what is in your theory. I don't want to confuse you. Okay, entity provides identity to the certificate authority. So now let's say Instagram. This Instagram is the entity, it wants a certificate. So what it will do, the Instagram will create, it will create public key of Instagram and private key of Instagram. Now let's say this is certificate authority, CA. Okay, now what it will do, the Instagram will give its public key to the certificate authority. It will send its public key and also it will send the information about the Instagram company. Now the certificate authority will create a certificate. This is a certificate. Inside the certificate it will put the Instagram public key. Okay, Instagram public key of Instagram will be there in the certificate. Now entity provides proof of identity to the certificate authority. So the entity means Instagram. It will provide its information, its address, all the business details which are relevant, plus it will give its public key to the certificate authority. CA, certificate authority, will create certificate and will put the entity's public key inside. So certificate authority will create a certificate and it will put the this entity public key, Instagram public key, inside the certificate. Certificate containing each public key is digitally signed by certificate authority. Okay, so what happens, students, CA, what it will do, it will create the digital signature. It will create the digital signature for this certificate. Okay, so I don't want to confuse you. Actually, digital signature means hash value is calculated, the hash value is encrypted using the CA private key. So digital signature is created and digital signature is also inserted inside the certificate. So the step is the entity provide the information and its public key to the CA. CA create the certificate and in the certificate it will insert the public key of the entity. Also it will calculate the digital signature and put the digital signature inside the certificate. So now the certificate is ready. Okay, so just now I showed you the certificate. Here, go here, click and details. So here you can see thumbprint. This is the certificate. Understand, this is the public key and this is the certificate authority. Understand? So students, how certificate authority creates certificate? Entity provides proof of identity to the certificate authority. Certificate authority creates certificate and insert its entity's public key. Certificate which contains a public key of E is digitally signed. Okay, so and the digital signature also inserted into the certificate. Protecting the data at rest in motion and in use. So please understand, so we have discussed about the symmetric encryption, asymmetric encryption, hashing, then digital signature and certificate. So using these schemes we can protect the data at rest. When you have data in your computer, in your flash memory, in your hard disk, this data can be protected. As well as when the data is sent across the network in motion, it means when you are sending the data through the internet, through the network, then also you have to protect the data. So data at rest means the data when you have in your system, in your mobile phone, in your laptop. Motion means when the data is transmitted across the network. Protecting the data at rest is important because the large amount of stored data can be found on devices such as backups, tapes, flash. Okay, so you have lot data in the devices such as flash memory, hard disk. Okay, also you are sending lot of very important data across the network, that also should be protected. For example, you go to Bank Muscat, online banking. Okay, so you can enter your username and password. These are very important. It should be encrypted. Otherwise, somebody in the network, they can capture this message and they can see your username and password, right? So you can see it is already encrypted. That's why you can see this secured website lock, padlock. The certificates are used, symmetric as well as asymmetric cryptographic algorithms are used, hashing is used, digital signature is used. All whatever schemes we have discussed so far is used to secure the data in motion. As well as when you store the data in your system at rest, you have to secure using these schemes like encryption techniques, hashing, then digital signature, etc. Many solutions exist in protecting the data at rest. The primary method we use to protect the data is encryption. So when you want to protect the data, please understand, you can go for encryption scheme. If you encrypt the data, people, they cannot see the plain text, because unless or until they have the key, they cannot see the message. Okay, you just think like that. You have the laptop, in the laptop or in the hard disk you have lot of important data. Okay, critical data, chapter number 7, and these data, if someone gets the data without any without any rights, if they access this data, it would be a big problem. Example, the teacher has exam papers, question papers. If they miss the laptop or the hard disk, okay, big issue, right? Similarly, okay, a lot of sensitive data are there. So to protect such kind of critical data, the best solution is go for encryption. Prevention of theft by implementing encryption for portable devices. The features of such commercial products often include the ability to encrypt entire hard disk, known as full disk encryption, and a variety of removable media using number of free and open source market. Students, TrueCrypt and BitLocker are the techniques which can be used to encrypt your hard disk, entire hard disk. Okay, DMCrypt also is another tool. So TrueCrypt and BitLocker can be used in the Windows, and DMCrypt can be used in the Linux. So please note down, if you want to protect some data in the hard disk using encryption, then you can use these tools, TrueCrypt and BitLocker in the Windows and DMCrypt in the Linux operating system. So next, actually here what we discussed is about securing the data in the system as well as in the motion. So the best solution is we can use the encryption techniques, symmetric as well as asymmetric encryption techniques. Okay, and also we can use the hashing, we can use the digital signature to provide a comprehensive security. Okay, so if you want to encrypt, these tools can be used in the Windows, and DMCrypt can be used in the Linux. Physical security is another important step in protecting data at rest. If we make it more difficult for attackers to physically access or steal the storage media, see, physical security means, listen, we have a server in some room. Okay, we should protect the server. This server might have a lot of data, database system. You might be studying database course, for example, bank database has all the information about the customers. SIS database contains all the information about the students. Employee information system contains all the information about the employees, salary details, etc. So protecting this data is very important, and these systems are placed in some place. Okay, so for that place also we should provide security. That's called physical security. Who can go inside that room? Okay, is there any proper permission? Only with proper permission they should be allowed. Unauthorized people, those who don't have the permission, should not be allowed. And also the systems has to be protected against from fire, flood, water. Okay, so unauthorized access. This is called physical security. Clear? So when the data is sent across the network, please understand, when you access the bank applications like username, password, the high security is needed. Of course, these sites are highly secured. Communication between our browser and the bank server is encrypted. Okay, there are some protocols used that takes care of the encryption, decryption, hashing, etc. Okay, so another major concern to protecting our data when it is in motion over a network of some variety. This might be closed WAN or wireless network over the internet, or in other words, the primary method of securing data from exposure and encryption. Once again, encryption. How can you protect? You can use encryption. Also you can say hashing. Okay, then you can digital signature, certificate, all whatever you studied in this lecture, all these are used, okay, to provide the security. Protecting the data itself. We can take a variety of approaches to protect the data we are sending over the network. So SSL and TLS are security protocols, students. So here this communication between this bank and our browser is secured using this SSL and TLS protocol. Okay, TLS is used, and they operate in conjunction with other protocols such as IMAP, okay, POP. So please understand, IMAP and POP are the protocols used for email, sending and receiving email. HTTP is a protocol which is used for web communication, web traffic, like website. This is HTTP and SSL together, HTTPS. Okay, HTTP and SSL for security. So please understand, these protocols SSL and TLS are very important to provide the security when the data is transmitted, when the data is in motion. And VPN, virtual private network, is also another way to protect the data in motion, protecting the connection. Suppose, students, you want to connect to your office company from your home through the public network, then the company can support you with virtual private network. So when you connect to your company from your home through the VPN, there is a secured connection between your system and the company network. That's called virtual private network. So far we have seen so many schemes. The last category of providing data involves securing it while it is being used. Although we can use encryption to protect data while it is stored or moving across the network, somewhat limited in our ability to protect data while it is being used by those who legitimately have access to it. Authorized users can print files, move them to other machines. So students, we have so many schemes, but still when you deal with the data, for example, you are sending a printout, and that document printout has very critical data, important data, but after giving the printout you forget to take the printout. Somebody, they take the printout, and who is not supposed to the person should not have access that document gets access, then it breaches the security. So the point is, even though you use a lot of encryption techniques, certificates, hashings, firewalls, intrusion detection systems, so many protection, security, but you have to deal with the data. When you deal with the data, especially when you give printout, you send an email, you take care that it doesn't reach the wrong person. So with this I conclude this lecture. Thank you.